So welcome everybody. I'm gonna get in focus. And I will share my screen. Okay, welcome again. Here. Please go into the document, and I'm going to start on page 1. So actually, in this doc, please put your name in and make a little icon for yourself so we can do that. And I actually want to capture people and skill sets there's a lot of talent coming into the program from people who have built homes and general contractors and builders and all that. So please make your icon, like I did my little MJ thing. If you look at it, it's open source. It's a box, and I just put letters in there. You can use that and copy that and modify it if you like for your own. When we talked about role allocation and major breakdown of the house into parts, you guys can see my screen?
Yeah.
Good. Okay, so I'll continue here. So role allocation. So this is part of the little collaborative editing thing, but all of you right now can be editing that and adding yours. I would like to see this popping in with people's names, and I'm moving Jackson here. People's names and their skill sets. That helps us when we allocate roles. So when we go through the entire build, we can have a better idea on that. And the idea that we mentioned yesterday, the goal for today is to generate cheat sheets, generate some module maps. So the map, master index overview, sections of the house, A, B, C, D. These are conceptual diagrams. You've seen this yesterday. The living room, kitchen, bathroom. There's broken down parts of one of those modules conceptually. What about this? Hey, here's the next one. Floors and decks, 14 modules. So I actually did that just before the meeting. This is the floor of the house. All the different sections. So it's broken into about these sections. The long 6 main floor modules are 6 feet wide by 20, and we can have a team of 2 build that. That's relatively easy to do. The deck is broken down into many modules. In the CAD, it's actually in 3 pieces, but since we have so many people, we can break those into 6 so that they're easier to build. The back veranda has 2 modules. So that's where we're at. Front veranda has 14 modules, so we can call those 50 through 63. Oh, what's... No, messed that up. That should be 50. So we're calling this, I don't know where, I was maybe tired. So 50, 51. So the numbers, the organization of calling each item by a number, that helps us track everything. But those numbers cannot repeat, because otherwise people are going to build twice of a module or something. So we got to get that straight. So I'm going to just correct that here so we can actually edit this. But if we open up the CAD file, you can, the first thing we can do, let me just finish this thing. I need 56, 57, 58, 59, 60, 61, 62, and 63. So 14 modules from 50, it goes only up to 63, not 64, as I found out. Let's go into the CAD and let's see what else we can do. So how about we do this? What if because we already have 63 items, and that's about a third of everything. So 63 items, let's do exactly the concept of slide number 3. Cut and paste maybe a little image with link to the CAD. So what was this? A link to the CAD. Just to show you an example of what that looks like, look at this. Did you know that this thing, when I click on that, I'm going to be taken to the CAD. It's right there. The way the CAD, so this takes you right to the wiki through a simple hyperlink. When you do file uploads, the way you do that, so say you want to do a file, you're extracting the file from the main CAD model. How do you put it on a wiki? Well, first you need an account, but after you have an account, let me show you a sample file upload. So I just created a new page, created it, edit to create. And for you to be able to upload a file, one way to do it is simply say file, and then file name. The extension name for FreeCAD files is FCSTD. So you do that in double brackets. File, double brackets, file name.fcstd. You save that, and now when you click it, it asks you to upload it. There you go. So you can choose a file. I'm going to just select something off my desktop here. I'm going to just pick any FreeCAD file. And then you upload file. You can put a summary of it. Ignore this. So sometimes you have files that have similar file names, and it will give you a warning, but just ignore it and save the file anyway. In a summary, so you can add notes. I don't have any comments here. That would have gone in a summary. Uploading a new version of this file, this is version history now. So if you upload it, don't be afraid of uploading into the wiki. It can be deleted. It can be, a new version can be uploaded. So if, say we are doing any kind of a documentation, we want to update something. Here you just upload a new version of this file, and it'll ask you for that. And then you put file changes, like I changed something, X, and then upload file, but I don't have a file selected. So this is version history. It'll tell you who uploaded it, so you can actually track down and ask questions to the initial person uploading. And that's that. So that's an explanation of this right here. So if you do your cheat sheet, link to the CAD. That's perhaps the most important. You're in a workshop, you've got this printout. You click on that and you get right to the CAD. That's a grand simplification to access all the information immediately. Cool. So next thing here is do the module number. Once we build it, you can put your icon there. Title it, like for example, floor modules for that slide I showed you. Start working on a cut list, or just do one. Like start with the file screenshot and file upload. Do a title. Start working on a cut list. So we can actually start doing this in parallel, and let's do it. Let's do it. So we've got all the people here. What I would like you to do, and I'll continue working in parallel, but each one of you can create a slide. So you can do either like slide, new slide. When you do new slide, it'll just give you nothing. So what I typically like to do, I like to just delete that. What I like to do, if you want to do your first cheat sheet, I would do a copy of something that already exists. Like what we like to have is the open source ecology branding and license info. That's useful, so people see that, oh, this is open source, it's CC by SA Creative Commons license. That's an open source license. We do everything here open source. So you can take this as a template, go to right click on it and then just do duplicate slide. So feel free to do that. And then, hey, let's start 1, 2, 3, 4, 5, 6 to 46, and we got as many as 63 already. That's more than we can handle today. Let's do it. How do you do it to coordinate with people? You can speak up in a conference call and say, hey, I got this. I'm going to take number 1, or just put your, in this index here, you can feel free to put your name on it. So do I see Jackson, for example, doing this one? I'm not sure. If we do, that does look like Jackson would be working on 1, but you can actually, if you want to auto allocate roles here as we're doing these cheat sheets, you can just put your name next to this. Put your little icon, your name icon next to a bubble and say, okay, I got this. So now, say whoever has number 2, make a copy of the slide, start inputting all the information, starting with the screenshot, then go to cut, listen, all this, start generating the cheat sheets. Don't be shy. This is about creating placeholders. Even if you have no content in there, as long as it's clear what you're doing, like, okay, this is a cheat sheet. People start seeing things like, oh, there's a number in the upper corner. People will start recognizing that, oh, okay, that's somebody working on that module cheat sheet. So before we go further, any questions on what this process looks like from anybody?
The rooms and floors. We're not copying that one. We're actually copying slide number 3, right? We're doing slide number 3.
You want to do slide number 3. Well, because this is a template. That's like a template.
Yeah, we just copied the template.
Just copy it. I mean, it's a crappy template. Of course, we can, like, if we had a graphics artist in this conference call, somebody would make it pretty and format it nicely. Here we're just saying, okay, anybody just go for it, just do it. We can always add the graphical design later, so it's an incremental process.
It's fine. So if we're doing wall modules and I say I want number 7, I'm thinking I'll make a comment. I'll highlight the number 7. I'll make a comment on the page and I'll say, I've got this, instead of like a text bubble.
How about on this? You say you want 7. Why don't you just copy and paste your icon right next to it? I can tell you, oh, Keith's doing 7. Does that work? Or
yeah, I mean it's gonna get messy.
You're saying this slide's gonna get messy?
Yeah, if we paste a bunch of images on there, but
yeah, it could get messy.
Yeah, it's difficult to also see that comment that's on 7, isn't it? Yeah.
Yeah, the way I imagine that looking. So say I mean, these are like critical orientation issues, but get a load of that. For example, I did that. So like I would do, say I take 6, I would do that. Not particularly messy, but yeah, it could get messy.
Well, we can try it.
We can try. But somewhere you got to do, okay, we need to let everybody know what we're working on if there's a whole bunch of people. So you can speak up. You spoke up, you said, okay, I got 7. Andrew's got 19. Great.
Hey, Keith.
Yeah.
Keith, can you alternate? Somebody put their name on the inside of the box, and like, for instance, somebody's put it on 7, you want 7. You put yours on the inside of the box. Somebody who wants 8 puts it on the outside of the box. You follow alternate? I don't know if you can do that or not.
Yeah. Sure.
I don't know. I'm not savvy to that.
Yeah, I just moved it south of 7. Sure. Yeah, go ahead. So this is role allocation, and I think that's kind of cool that people are developing stuff. For another point of orientation, you see the XYZ origin. I put a red dot there, but that's down the road. If we were to ever be designing, or actually we're talking about the house and communicating about it, call that the origin, so that everything relative to that is, so south, north, east, west is relative to the origin. You're looking at the front of the house, the big double door, it's a French double door. That's the front. And we're calling XYZ that bottom left corner at the bottom of the house on the top of the floor as the 000. Because, why? Because it's a very convenient place to locate different things. And we can now share a common language saying, okay, I'm at, 1 foot off the origin. You can say, oh, I'm 30 feet off the origin to the east. And you can say, oh yeah, that's actually the far corner. So it's a technicality, but it'll help us communicate. Just understand that red dot is the origin of the house. So you'll hear me talk about the origin throughout the workshop, and as we do this build, it's a good way to organize so that there's no ambiguity. Like, we're talking about the house, which corner are you talking about? No, it's clear. That's the origin, and we have north, south, east, and west. That's the references.
Yeah.
Now, one thing I want to let you know is that, so you're doing build instructions. Well, guess what, guys? From the last build, we already did all the framing modules, but we did not add the OSB to it. So we found out that a lot of times it was confusing. Well, which side does the OSB go on? The sheeting. So we do have all of the wall modules, and that is under, so I'm gonna just give a link to that. It's under SH6, under build instructions, and wall modules 1 through 50 are right there in link 1. So here, so I'm going to paste this link. Here you actually have, so for example, what is wall module 1? Oh, it's that. Look at that. We already have this. Well, too bad it's incomplete because it doesn't have the OSB, and you need to know which side. Well, on this module, it actually doesn't matter because it's symmetric, but a lot of times it will matter which side the OSB goes on. So you can copy and paste that, but then maybe just annotate this. Okay, the OSB goes on either side. And from this, you can, for example, start taking, oh, here's the build instructions. I'm going to cut the bottom and top and use 3 pre-cut 9-foot studs. Space them as such and such. So we've got this resource already that you can build upon from the last time. So let me go put this link as SH6. I'm going to put it right here. SH6. Wall module tech drawings. Now, this was actually very painful last time because the tech drawings did not have OSB. Oh man, that was a lot of confusion. People put OSB on the wrong side, or they were asking and confused. So that kind of stuff needs to be absolutely transparent. So in these cheat sheets, make sure you include that. So I'm gonna put a link to that.
Are we? Do we have to go through the dock and find all the walls? Because the walls are not together in here.
You're saying at the SH6 wall module tech drawings PDFs?
Oh no, sorry. Inside of FreeCAD?
Yeah. No, they're not organized right now. So one of the tasks we can start doing when you do make your file, call it appropriately. Call wall module 1. What's it called in a CAD file? I'm going to open up the CAD file right now. It's probably not called that. It's SH. Here it is. I'm booting up SH7. One note regarding if you bring a laptop, you can feel free to bring FreeCAD 16 and the latest version if you can actually download the OSC Linux. That's for more technical people. But why I like FreeCAD 16 still, it's super easy to get these technical drawings out of that. Okay, so in a CD Home 7 assembly, well, that's our module 1 right here. And here the label is wall FR left 001. That doesn't make any sense. So front left 1. Now just call it wall module 1. Keep it simple. So that you can do that. Can everybody on the call right now proceed with starting the cheat sheets?
Yeah.
Okay, and what I will do is I'm going to go into the CAD file and continue generating the index files, meaning, okay, here's the next module, like say the veranda, here's the roof module. I'll keep breaking down the module, but right now you got like 60 items. That's going to take a bit of time, so I can quietly work on separating the model further, but also feel free to ask questions and talk to each other, and we can all talk.
The hyperlink that you would like us to add to the image in the upper right corner of the slide, is that a link to the CD Go Home 7 CAD or to individual?
Individual. The idea.
So drive, is that right? Or
no drive. Do it right on a wiki. So if you put it on a wiki, we own it. And make sure it doesn't disappear on us sometime. Like if you put it on your own drive, if you disappear, the file disappears. So just put it on a wiki.
So we're starting with the whole CD Go Home 7 file, and then we're trying to drill down into the individual, like wall number 19.
Exactly. You do.
And then
yep.
Wall, and then I'm going to just show wall number 19, and then I can somehow export just the part I'm showing to its own FreeCAD file. Is that?
Exactly. The idea of this whole exercise is absolute clear modular breakdown. Each page has just one module that a team of 2 people build, that is printed, that is put into the finished folder after quality control. So it's a very granular, clear process where we can track everything easily. And it's both digital, because you have this on a computer, and then we print it out, and you can work from it during the workshop. Does that make sense?
It does. How do we export that FreeCAD file once we're showing
Okay, so let me show you that. So if you go to the FreeCAD file itself, it's as simple as Control-C and Control-V. So for example, if I'm going to do wall module 2, I'm going to double click on it, and I'm going to go Control-C, and then go to File, New File, or you can just click this plus button for a new file, and now it opened up unnamed one, and I'm going to do Control-V. I just Control-V'd, nothing happened. You got to click on this button which centers it. Okay, that brought it into view. So you see this button here is the Fit All button, or you can do V on a keyboard. You can do V and F. So for example, if it's not visible, I can hit V and F on a keyboard. It just did it, or you can just click this button.
The right clicking also brings up the context menu and gives you that option.
Awesome. Right click, yep, Fit All. There you go. Now you can save this, so do Control Shift S, or just Shift S. Well, Control S. Yeah, it'll open up a dialog. Save it locally. So I'm going to say wall module 2, and then save. It's saved on my desktop. So now I have that file, and now you can do the upload. Have you seen what I showed on the wiki? From here.
Yeah, it's on the file part. Yeah.
Yeah. So now, where do you put it on the wiki? Well, this is still 3D CAD for CD Go Home 7. So at CD Go Home 7, you're going to go to the CAD. And here, this is what we're doing. So walls 1 to 48. Let's do wall module 1.fcstd, but I forgot the file, and that shows up. So that was wall module 2. I just show number 1. So that's what happens if you do that syntax. It'll give you a hyperlink that you can now upload. So it gets you the choose file dialog at that point. So now you have put, so here, this is our 200 modules on the Seco Home 7 CAD page. List them all here. I'm starting to break them down here. So for example, here I downloaded, uploaded the floors that I showed you. So right there, this file here is what I uploaded on the slide I showed you before, which is this one. This one here. So, and what I like to do is when a thing is hyperlinked, I like to put a blue box on it so you know that it's a hyperlink. Otherwise, you might not even know that, oh, that's an actual file or something behind that. Yeah, cool. So here you click on that, and yeah, it goes to the wiki, and it gives you the file. So when I click on that, it goes back to that file. And this index now becomes our version control. So say you made some additions to your to your wall module or a technical drawing, because yeah, within a single file such as the what I showed you as this file here, you can, if you know how to do the tech drawings, you would save that tech drawing within the same file. So that's what I'm saying. The new versions, you might have updates even to the CAD file, or if we say change this and we decide to put a wall outlet for electrical and some other details here, or insulation into this, and then we can upload a new version of this wall module if that is to be built in that same cheat sheet. So for example, I could see things like, okay, here's an electrical box in there. We're actually pre-wiring this. Okay, I would upload a new version of this file. Going to here, I would just upload a new version of this file. So this is a version history, and now because you're making your cheat sheets that are hyperlinked, you actually took the version history right into your cheat sheets to be super convenient. So the whole idea behind this build book is that, okay, this is absolutely everything, because there's so many pages on the wiki, it's maybe confusing. Here's one document that has absolutely everything, and it links to everything else. So this document serves as an indexical environment for all the work that we're doing, and it has the index for the master indices like these, where we're allocating tasks and so forth. I'll be quiet and let people work now. Any questions?
So I joined a little late. We're basically choosing a random module that we want to build the cheat sheet for, and just building that. Okay.
Yep, and put your name on slide number, right now that's slide number 10. Make yourself a little name icon on page 1. People are putting their name icons and skills. Make yourself an icon so that to let people know that you're working on it. Put your icon right on slide 10. Let me know if there's any more questions.
So should we communicate which module we're working on? Like
yeah,
I'm gonna do the kitchen island, I think.
Okay, cool. Yeah, I mean, but you have to. So right now, let's limit ourselves to 1 through 63.
Oh, okay.
Yeah, we're not there yet. Yeah, the island is going to be a module by all means, and we're going to probably break it down into, like, when we build the kitchen island, there might be several things. There's a countertop there. There's a cabinet surrounded that might have several modules associated with it that people can build. But right now, the index that we're working from is slide 11, and I'm going to put the next one, the 12. Well, let's put all those up. They should be actually up front, so you can basically move these slides around. That's convenient. I just moved them up to the top so it's easy to. Oh, just one. I lost one. I'm gonna move. this one to the top. So now the slide number 1 and 2 are the ones where we've got the index of all the modules so far. Slide 3 is the yeah, 3 is the template. Oh, actually, that is, no, maybe not. That's Keith. Maybe. So the original template is right here. Okay, so this one, let's just make copies of this slide number 3 as the template. So we're going to be like, don't touch this. I'm going to put a bit red thing, don't touch this. This is our template.
So, looking at that slide that has all the modules, there's a lot of modules that are repeated, right? Like modules 8 and 9 are the same.
And you don't know that exactly. They probably are, but for the sake of it right now, because we're tracking everything, like for example, we don't want one person just to build like 5 of the same module. So for that reason, we're just separating them. Just pick one and don't worry about the others being the same. Does that sound like a good idea for everybody, or does somebody want to make like 5 or 10 of something, like just repeat themselves a whole bunch of times?
Let's do everything.
Yeah, let's do everything. So you want to just take one and then, yeah, move on. And that's for that reason we're itemizing every single module.
Hey, Marcin, can you speak to what the cut list would look like potentially?
Oh, yeah. Sure. So I'll go to the wiki and go to cut list for some examples. So that's an example. Now that's like all out for this complicated thing. What was this? Oh, that was actually, oh man, that was the stove I built a few years ago, a hydronic heating stove with heat exchangers. So this is what I did. This was actually in metal. For here, it's this is a good example. For yours, it's going to be much simpler, but do the item brackets, do like the quantity, and then describe it as much detail as possible. For now, we know that the lumber we're working with is 2x6, and we also know that the 9-foot members are called 9-foot pre-cut studs, which are 3 3/8 inch shorter than 9 foot. But that's an example. Does that answer it?
Yeah, I'm considering also trying to write some kind of Python script for
there you go.
For the cut list to automate it.
Yeah, absolutely.
Like I don't know if you saw that file that I sent you, but I was using downgrade in the draft workbench to split everything up.
Oh, cool.
So, and that's been working pretty well for separating everything. So I was considering, maybe trying to do that.
Yeah, I mean, see, that would help. And now if you do that, your responsibility is for it to be useful, is make it so simple that anybody can do it. So do a little instructional and maybe do a little video and teach everybody else. We teach by, we learn by teaching.
Robbie, you're connecting to and scripting this out in Python.
Yeah, that's the beauty of FreeCAD. You can program it.
Yeah, it's the libraries are a little difficult to get to. I'm trying to do something similar, but I want to pull it into a Postgres database.
Yeah, and you know what the ultimate game here is? There's a page on the wiki. I'll entertain you with this, but the FreeCAD, there's a page called FreeCAD Workbenches Platform. Do we have that? This tells you, this is advanced stuff, this is for power users, but there's a method by which we actually build new workbenches in FreeCAD. So for example, what does that mean for the house? That means you will have icons here and they'll draw you the right things, like, okay, give me a wall module, a kitchen, a floor. And so you're basically automating or simplifying the design process, but that's a big project. It's like for somebody to design this house using like drop-down menus and things, that's quite a bit of programming, but that's the end game to make this absolutely doable for anybody, because this CAD model, I mean, took probably, I don't know, like 100 hours. It takes a bit of time. I mean, we've had some of these modules from before, but I mean, there's a bit, I mean, hundreds of hours in this model. So think about it, if you can automate some of these things, but okay, now just insert me a wall module, insert me like these PV roof ties or whatever, this or that window. It's that now it's called the FreeCAD open source home designer workbench. It's just amazing, and we look forward to once that happens, because then people can redesign different versions at any time without the beauty of that is that you embody the engineering within the workbench, so you don't have to think too much about what you're actually designing, you know. So yeah, it's a powerful tool. I personally think that FreeCAD is going to become possibly become a dominant platform in the future, because it's programmable and it improves all the time. Okay, I'm going to get into, also again, feel free to ask questions.
Is there a way to search for a part, or do I have to kind of drill down through the whole model?
You kind of have to drill down, but you can also just simply double click on it in the graphical interface. That's one way to access it.
Okay.
Okay, so I'm gonna start extracting the veranda modules. Roof. There we go. One hint, if you right click on it, you can actually select a random color. I kind of find that useful, because then actually it disambiguates the different parts.
Hey, Marcin.
Yeah.
I have a question. When I was going back and reviewing the last video, and kind of stopping and pausing on this one here with the verandas on it.
Mm-hmm.
Why do you got the posts? How come you didn't use an LVL beams on there? Is there a reason? Was it cost or what?
What's the question? Why are we doing the trusses like we are?
Instead of all of those posts that are in the way of your viewing, how come you just didn't put an LVL, a free span LVL in there? Like, say if that's 20 feet, you don't have that much load on there because the rafters aren't there, the ceiling joist. So, you wouldn't need, say, a 14-inch tall beam, maybe a 12 or a 10, inch and 3/4, twice, and then you got a free span of nothing interfering with your visual.
Yeah, that might be a good idea. Now tell me the price.
Well, I just don't know. You know, you got 6x6 rough cedar there. Those suckers are pretty expensive as it is. There's what, 4 or 5 of those. Then you got the front porch. Might want to check in on the cost, and you know, you got to get an engineer to.
Okay.
You got to know your span. You got to know your load.
That's actually, you know, I think that's actually a great suggestions here. I don't like those posts myself. I mean, they're heavy. So, yeah. Now for the LVL, that also will be quite heavy, wouldn't it? But yeah, good hint. If the price is right,
it would be heavy. It would be heavy, but buddy, it wouldn't deflect, and you got so much better view. I mean, it would sell that house in a heartbeat. Somebody walks out there and their visual isn't obstructed.
Okay.
You know, they got a wide open view of the yard or whatever they're looking at.
Yeah. No, you might be completely right, and the price might even be like the same or lower. I don't know. Okay, good idea.
Yeah, they're not that hard to put up.
Okay, I'll take it to the design department, Katerina.
All right.
Yeah.
I can't edit the wiki yet. You know, I requested the account, but take your time.
Yeah. Sure.
We can do that later.
Please request the accounts. They go to. I approve that, so I'm just gonna approve all of that. In fact, that's that goes. That's the special pages. Confirm accounts. Yeah. If you don't have an account on the wikis, please request one. Oh yeah, and try to do the time log if you can. I did mention a time log, and if you guys go on a page called time log, because these hours count as development time for open sourcing the economy. Did you know that? So the graph on my page, this graph here, it tracks the entire effort in the hundreds of hours per week. So at most we had like 500 hours in a week. I mean, this is like complete startup territory. This is not like thousands of people putting a bunch of hours, but we're tracking the time and effort to open source civilization. So it's called OSE active development and development effort. If you get a time log, your time hours that you log in there, like say you're doing a session for 1 hour, that actually gets added to this main graph.
Our username and password are going to come for that at some point, right?
Yep. So that should, Keith, you just should get that. So you got to approve it. Yep.
Right. That's part of the wiki username password. Got it.
Yep. So for anybody else, there's on the upper right, there will be a request account button on the wiki. And that's what you got to click. Then I will approve your account to edit. And you got to do that once, and you keep your password. Then you can go log in.
Who's doing 13? I'm trying to copy off of you.
Oh, I'm doing 13.
So Bo's got 13. You can see that in the master index for the wall modules. So we call it the wall modules master index.
And we want to get measurements in inches and centimeters.
At the bottom right, click on the, there's the units box. If you click on the bottom right thing that has the dimensions, select building US as the measurement system. Bottom right hand corner of the FreeCAD window.
I think it might be a different process in Windows to change that, but I'll figure it out.
Okay.
Andrew, yours looks good. You've got some tools in there. I'm assuming that
Yeah. Drill and a saw.
drill and a saw is probably correct.
Yeah, Marcin, how do we know which fasteners we're supposed to use?
Yeah, that's I have to say that. So, in the workshop itself, because we have so many people, cordless drills can be used at any time. There's air tools, but we're going to use cordless drills largely. We can have some people do air tools as well, but we don't have enough air tools for everybody. But cordless drills are much easier to access, so we'll have both nails and screws. For screws, we're going to do 2.5-inch 2.5-inch wood screws. Star drive, we always use star drive screws, like you see in the Fab Tool icons. So Andrew, you dipped into the Fab Tool icons thing. Yep. Yeah. Did you pull that off the Fab Tool icons, or no? You.
Yeah, that
Okay,
link
yeah.
you had.
Yep. So we mentioned Fab Tool icons, which is because those fasteners are also in the Fab Tool icons. So I'm going to put that into. Oh yeah, that's linked. Fab Tool icons right here on the template. And then nails, 2 3/8, just nails that we just nail this off at the end if you got the OSB. But for the wall modules, yeah, impact driver guns with screws. Oh yeah, so for the corners, those are 3-inch screws. 2.5. I was talking about the OSB for 2.5-inch or 2-inch screws for the OSB. You always want to have 1.5 inches of penetration, so the minimum screw is 2 inches for the OSB.
How do we know if we're using nails or screws? Are we using screws for all of the wall?
I would do so. It's going to be what the practical implications are. Everybody can start off on the screw guns. People who have experience with nail guns could use nail guns, but you can assume I'm going to be screwing this in. And that's a highly scalable process because it's much easier to access a drill than an air gun. You also need air supply. For so many people, you need a big compressor and stuff. So,
And then how many screws would we use for?
Yeah, so that's good. Good questions. And on the perimeter, it's every 6 inches. In the field, so for example, the middle post, middle studs, those are every 12 inches. But on the perimeter, when you've got OSB 2, the framing, 6 inch. Now for the ends, use 3 screws, 2 or 3 screws for the ends, putting the frame together per connection. So you can also tally that up and say, okay, for the simplest wall module, I use 18 3-inch screws. And I don't know what the part count is. Actually, somebody can do that, what the actual screw count is for the entire module. If you do 6-inch center, it's about 70. That's a lot. And that's why you want to nail, because you're gonna get tired of that if you're doing the OSB. So we'll have as many guns as people are comfortable with in terms of.
Hey, Marcin.
guns. Yep.
Marcin.
Yep. Go ahead.
Yeah. You have, what size compressor do you have?
2 55 gallons.
Okay.
We got. Yeah, we're pretty good on that.
Okay. I don't have to bring mine.
No.
Okay. Thank you.
Marcin, could you explain to us how to set up a work log? Could you show us how to do that? Give us an example.
Yeah, work log. So click on MJ, or that's called a work log. You do, but let's go to the source page, which is work log. What do you want to keep there? You want to keep it's called a daily log of tasks. Just set up. It talks about how to do it. Just type in work log. Takes you to daily log of tasks. But how does it look all together? I'm gonna click on Michael. So what we do is at the top you request your time log at the top, so you can go look at time log. How do you request that? But the core thing is date and start putting hyperlinks to the work product that you're doing. So for example, on the 11th, I was working on heat pump sourcing. So you just put hyperlinks, which are wiki links that link to other pages on the wiki, because all the work we put on the wiki, you can also have external links, but I typically just like internal links so that we have the data on the wiki. Inverter sourcing, blah, blah, blah. If you want to know how to edit the wiki for formatting, the hyperlinks are double brackets, like you see here. A single equal sign gives you the main heading, and you got subheadings from there. But there's a page called Wiki Instructions. You can take a look at further instructions on how to operate on the wiki. But work log, date, and do a simple form, like I always do, like Wednesday, December, whatever. When the day, date, and year, and that way you can have another brain in the this is my brain. I put everything here. So for me, I've kept one since 2011, so you can see what I was doing October 2011. But it's cool because now I can access this and look at what it's been doing there. So on yeah, I mean, it's really cool because you can trace what you've done a long time ago. Like in 2011, we were pressing bricks and making the Hab Lab right there. Look at that. So there you go. But the work log is, I can't say enough about it. It's like keeping a notebook or adding yourself a brain, because you can reference everything, and it helps you learn, because learning is about repetition. You read something once, you document it, you type it in. It's just reinforcement learning. Mm-hmm. Hyperlinks and dates. That's the work log. Does that kind of answer it, or?
Yeah, that's great. I'll look up the instructions and I'll start my work log. Thanks.
Yeah. And definitely, I mean, this is serious development here. What you guys are doing, if we actually publish a complete guide for this house, you're talking about a real product that many people are going to replicate. This is not busy work, and it can evolve. You start it right now. It can upgrade over time. That's the beauty of this, for modular design or a design system where it improves over time. Just like technology should improve over time. We shouldn't throw something out in 90 days from Amazon. It should actually live forever and it should improve with time if you have it modular. Open source.
What do you put in the build instructions box?
Yeah, I mean, start making it up. If you don't know, if you're a builder, you probably know something. If you don't, you just start logicking out. If you've got, you tell me which module you got. Let's do
All 19.
Which slide number?
11.
Okay, so you got 11. Cutlass, cool. So I like the double bracket, like a bracket, because that makes it clear what that
Yeah,
is.
That's so standard.
Yeah. So standardize that to brackets. For build instructions, okay, so you got that thing. All right, cool. So you got the wall module 19. I'm going to download it. I'm going to open it up. And that's the thing. Like, you just did that, and now I got it right here. Quick, cool. Okay, I just downloaded it. Well, what would you do here? You tell me. Okay, you see like this closed box here. Well, what are you going to do first? Build instructions. What are you going to do? You tell me, because you can start.
Yeah, I suppose I take the 4 pieces of lumber there and screw them together into a box.
Yeah. So you got to start with, you got to cut some things. So you got to cut the top and bottom plate to 4 feet. That's your first line. Then get I'm counting 6 studs. What are they? What are those studs? Identify them.
Is there a standardized length for that? I mean, is it just a particular length of a 2x6, right?
Yeah, it's everything here is a 9-foot pre-cut stud.
9 foot, okay.
9-foot pre-cut, meaning it's 3 inches less than 9, minus 3/8 on top of that. So these are pre-cuts. So say, okay, I'm going to take 6 pre-cut studs from the lumber pile. Then you're going to say probably, way you want to build this thing is you want to, so here's the trick I mentioned the other day. Take your piece of OSB that's 9 foot, lay it on a table, put the 4 outer members on it, and attach it. Now you've got a rigid, solid outer box attached to the OSB. And then fill in the rest. So you can start writing that down. And then you can just write down that, if you kind of follow the procedure, what I just described.
I do. What was the OSB? I don't think I followed.
Oh yeah. So in the CAD model, so the thing I noticed you didn't do is put in the OSB. Now when we build the wall modules, the OSB is key because it allows you to do measureless design. It allows you to fit the lumber right up to its edge. So take a 9-foot sheet of oriented strand board called OSB, put it on a table, and attach the 4 outer lumber members to it on the edge.
This module here is going to have a sheet of OSB affixed to one.
Yep, affixed to one side. And now, you actually, here's an exercise in version history. So this is missing the OSB. Keep that file, just click on it, upload a new version, and add the OSB from the main CAD file, because you need that. The outer sheathing, we build that. The outer sheathing we build with the modules. So yeah, if people are at that stage,
Gotcha.
there you go. I'm just gonna do one slide here. It's 8 p.m. People can hang out here, or you can quit and do it another time. I'm just gonna do one slide.
So would we say like attach outer plates to OSB sheath?
Yep. Outer studs, yeah, I call them outer lumber members. Yep. We kind of have to formulate a coherent language here. So you would probably call those attach the 4-foot piece of lumber. They're called, I would say, top and bottom plate. The studs, the full-size members, they're called studs, the pre-cut studs. So attach the pre-cut studs, things like that.
Marcin, you have a top plate and sole plate. SOLE.
Yup. Listen to that man. He's built things before. So Roy. Yep. You learn some words like what all the things are
That's
called.
okay. You guys have got your work cut out for teaching me how to work this stuff that you're doing.
Yeah, exactly. It's multiple cross-fertilization.
Marcin, what kind of wood are we going to use, like for the 2x4s? Is it okay if we use kind of a cheaper wood to cut corners, or is that not recommended for the load?
Yeah, get the cheap stuff. SPF, spruce, pine, fir, standard stuff. And at Menards they have that. So yeah, just get. You don't need like high-grade lumber. You just get the cheap stuff.
Okay. Are we going to use wood glue? Does
Not
wood
for
glue?
these. Yeah. Not for these. The nails are fine.
Okay.
Yep.
If I can mention something to that about the wood species you're talking about.
Yeah.
Yeah, might want to check on that spruce to see the load.
Hey, Roy, you muted yourself. We can't hear you.
Roy, you're talking to yourself.
Hey, Marcin, so let's see. A 9-foot stud would be 108 inches, minus 3 inches would be 105. In FreeCAD, mine measured 104.6. Is that a problem?
Right. No. Here's the deal. Minus 3 inches, minus 3/8.
Oh, okay.
Yeah. I kind of use that to remember. -3, minus 3/8.
Got it.
But yeah, it accounts for the top plate and the sole plate. And there's that 3/8. I don't really understand that 3/8. Maybe Roy could explain it. Why do they make it that particular length? There's something about it that we don't build with the way that the pre-cut stud makes any sense. But Roy probably could tell you why that particular dimension makes sense.
Yeah, no, I'm sorry. I don't have an answer for that one.
Yeah, I don't have an answer either. They got this particular dimension. The minus 3 inches makes sense because it's the top and sole, but I don't understand that 3/8.
Yeah.
You just Google it and find out. Chat GPT it. What's up with that?
Hey, Marcin.
Yep.
That OSB is to accommodate three plates: your top plate, your crown plate, and your sole plate. So that's 4.5 plus your stud, because you have to have a top plate all the way around to tie your walls in, like you mentioned the other day.
Yeah.
But it's also for support on your load-bearing walls for your trusses to go, say, because they're not all going to end up over the top of your stud. So they're going to be in the middle of a stud pocket.
Yeah.
So, that 4.5 plus the stud length is we got to figure that out if that OSB is even long enough for that.
9
So
foot
you've
is,
got 104. Did you say 104 and a quarter plus 4.5 or four and a half?
so the OSB is 9 feet. So
Yeah,
we got the modules covered, and from there we build up.
right. Your stud length is 104 and a quarter, I think you said, plus the 3 top plates. That's 108. That's 9 foot. 104. Yeah, it's just yeah, it's a little over 9 feet. So actually, the USB should be shorter if you're going to use a top plate like crown plate like you.
Yeah, but no, hold your horses, because we actually use a double top plate later, and we bond that together later. So that's in the, you can take a look at the design for how it actually ends up. But the 9 footer of OSB, that spans the entire module, and it sticks out 3/8 inch.
Yeah.
Yeah.
Okay.
That's what happens there.
Yeah. Well, getting back to, I think by Mike, you said cut off earlier about the spruce pine. You may want to check about that species, Richard, if that was you asking that question, if a cheaper wood species, to make sure that, because you were talking about going 4 stories up or going taller, this, that, and the other a couple weeks ago, or the couple sessions ago. So you might want to make sure that that wood species carries that load.
Yeah, I
You
mean,
follow
getting
up?
into technicalities. Yeah, yep. I mean,
Oh, sorry about that then.
no, that's right. But what you get at the store, we never really asked that question, because we know, like, from code books and from experience, that okay, that's, we only get this thing at Menards. That's all you got. Well, if you have some other, I don't know what you got in California, you probably got the same stuff. So.
No, they got the good stuff over there, man. They got Doug Fir.
Okay.
They got the good stuff.
All right.
Marcin, what kind of foundation are we going to build on? Is there only a certain kind of foundation for this house?
You can build any kind of foundation for this one, from a slab to post to a stem wall. Since we're moving this, we're putting it on just the floor here, and we're going to pour. People want to get experience with concrete, so we're going to pour a slab, a sample slab, as well. You can do whichever kind of foundation you like. In our work, we're actually doing a stabilized subgrade foundation, which we'll talk about. Now, that requires engineering, so you can't just go to the inspector and say, hey, here it is, it needs to be engineered, and we're going to publish those reference designs once we find somebody who is a geotechnical engineer. We don't have that yet, so we're working on publishing all the supporting information for this.
Okay.
Mm-hmm.
So here's a question. When we're stacking the 2x4s or 2x6s together, and I see that there's a lot of them stacked together at some point. They look like load bearing. And how do we screw these in? Are they going to go just on one side, like we screw 2 together and then we add a third and we screw to that, and we just keep adding, screwing on one side?
Because if you put 2 of them together, the standard 3-inch screws wouldn't reach. So yeah, you got to layer it one after another.
So we never screw one on one end and one on the other. Do we ever do that, or is it always one direction?
Oh wait, I'm kind of missing the question. You're talking about just for the framing, or you're talking about the top plate, the double top plate? What are you talking about?
The framing.
Okay.
On the modules, there's some that are about like 6 I don't know, 8 wide. I don't know, several wide, and I'm just wondering, are they only screwed in?
Yeah,
I don't know. I guess I'd have to see it when it's all broken down.
You have to take that thing apart and now ask yourself, what's the logical order? And you figure that out. And at all times, you want to make sure that the way you're attaching it, you do a logical order so you can actually do the screw, right? So you just have to examine the specific detail and see how you get to that desired effect.
Okay.
Yeah.
Yeah.
Mm-hmm.
Will there be any vents coming out of the roof like an HVAC
No penetrations through the roof, only through the sides of the house.
through the sides?
Yep.
Okay. Huh. Okay.
Yep. The roof is a membrane. We don't want to put any holes in it. That's
Right.
bad design.
Okay.
Plus, we got PV covering just about all of it.
The piping? PV?
Photovoltaics, we've got.
Oh, right. PV.
Got
Yeah.
the PV pretty much taking up the whole roof. So, yeah.
Right. Okay.
Marcin, are we going to be installing septic, like the septic lines and the tank in the
We're going to do
yard?
septic fertigation indeed. We can do, so during the workshop, we can bust out the trencher, dig some lines for septic fertigation. We're going to do a pump vault where the plumbing goes into and gets pumped into a biodigester module, and from there to a septic fertigation system. Now, what we're going to do for the biodigester, we're going to do a separate module, like in a little separate room. That's going to be a modular thing that we can actually move that around too. Mm-hmm.
Okay, cool.
Yeah.
Is that kind of like is that a standard septic system, or is this something different?
Yeah, it's completely standard at open source ecology only. No,
Okay,
it's
yeah.
a complete freak show.
Right.
When you show this to your inspector, he's going to freak out. So then you're going to have to provide the engineering drawings for it. I'm serious. It's like stuff that makes sense is not in the code books because no, there's a lot of legacy stuff in the code books. That's another whole story. I'll talk about that. But yeah, it's like cool stuff that you want to do. A lot of this stuff, like for example, the trusses that we do, they're going to be tapered trusses. They need engineering. That's not in code. But it's the only way you can do it about a quarter the cost while getting the higher performance. I'll talk your ear off about all this stuff. So I used ChatGPT to design the trusses, so I could verify what ChatGPT was giving me. And I've got a design that's like, holy cow, like, why don't they do it? Well, part of it is that, so we're going to do tapered trusses. Nobody makes tapered trusses. They just don't. You can't get it off the shelf. But we engineered it, and we're going to install it. And it simplifies the build so much. So that's some of the examples, like the kinds of optimizations that we go through. But that's because we can design, build, engineer all at the same time. That's the thing.
If those things aren't in the code book,
Yeah.
would that still pass inspection? Like, would
Yes,
you need?
with engineering, you have to show them the engineer's drawings.
Okay, so you have like a professional engineer review the
Yes,
design.
exactly. That's exactly that. And our goal is to take that down to zero marginal cost, meaning that we get the reference design from an engineer who's willing to do it, to basically say, yeah, I published this and this is certified. But then we publish that as a reference for future builds for the same build. So therefore, you don't have to hire another engineer. You can just use that. Now, some building departments will tell you, no, pay more money to another engineer. So it depends where you are. But we're trying to make that easy. Part of the game here is to make the legal costs affordable. Because if you're going to engineer a whole house, I mean, it's thousands of dollars per house that you need to spend. No need for that. Yeah. So that's that. Okay, so I'm gonna actually, I gotta get going. But you guys feel free to continue working on. I'm gonna, of course, continue working on. Next sessions will be so next Thursday, once again, 7 p.m. same time. We'll continue this discussion. I mean, do as much as you can. I'm going to be putting in more master indices. Like, for example, I did slide 3 veranda, and it's breaking that down into all its modules. And one thing that we are doing, like, for example, the deck, as you see here, even on slide number, for example, 56, 57, we were breaking the deck that was like a 12-foot wide section. We're just going to break it into six-foot sections and make it individual modules, so more people can work on it in parallel. So some of the things in a CAD may be like these big roof modules for the veranda. We're just going to slice them in half because they're heavy, and so it's going to be faster to build and easier to get up there. So that's some of the stuff we do. So I'll continue working on a doc. You guys feel free to do as many of these, and start thinking about how you build this stuff and writing instructionals, and that will help you think for the get much more prepared for the game day itself. Yeah. Okay. So any last questions or?
Nope.
Cool.
Thanks, man.
Thanks a lot, guys. Party on.